Normally, and I tried doing that on this thing earlier, I would suggest you immediately go to Y1, Y2, and I tried to do this earlier with a strategy on a calculator, but it kind of failed on me. So the creator of this question is actually trying to make sure you can do a little bit of math. What I'm going to do is I'm going to think about my properties of exponents. The left-hand side is 2023 raised to the xy, and the right-hand side is 2023 raised to the x plus y. Now, because I have the same bases, I can literally say xy equals x plus y. Make that text a little bigger there. Xy equals x plus y. And the question is, for which values of x are there no values of y that make the equation true? No values of y that make the equation true. Let's go ahead and do a little work on this one. Let's move everything to the left. F minus x plus y is now a 0. Oops, xy minus that. And actually, do we even need to do that? No, we don't need to do that. So these are x values. Let's plug them in and see what we get. If the natural log of 2023 y equal to the ln of 2023 plus y. I'm sure that's solvable. Just out of curiosity, I'm sure that's solvable. Should be. I'll have to use the X key. It's just two lines that are intersecting. That's all it is. There's one line. There's the second one. So yeah, that definitely has an answer, doesn't it? So it's not that one. And I had to do this step. If I tried to do any other calculator cheats by plugging that in here and here, it was an exponential equation and the calculator was rounding too much. The author of this question actually tried to nullify the calculator, which is pretty impressive in its own right. So let's plug this one in here for y. We'd have 2023 to the, sorry, plug it in down here, plug in a 1. We'd have x equals x plus 1. That is definitely solvable. See, this is also lines. They're going to cross paths. Maybe not. Let's see what that looks like. And no, I'm talking in my butt right now. This one has no answer. My mouth got ahead of my brain there. What we have here is we have two parallel lines that will never, ever, ever, ever cross paths. See? Parallel lines, no intersection. Correct answer is B. All right, 21. Consider a triangle whose vertices are the origin and the intercepts of y equals 5 minus 2x over 3 plus 2x. What is the area of the triangle if the point 1, 0 is 1 centimeter from the origin? So let's graph this funny looking thing. That way we can get some stuff off of it. Math, num, n over d. I think I've got enough time to do this video. I got 7 minutes to do this question. And I think that's one thing that's going to get some kids is time consuming. Teaching this stuff is taking a while. It is. Anyway, zoom 6. And it says the vertices are the origin and the intercepts of y equals. So here's an intercept right here. I don't do this very often in class, but second trace value at 0. Looks like y is 5/3. Cool. Second trace. Oh, let me put a 0 here. This I teach all the time. I need the x-axis drawn. Second trace 5 for intersect. because I need that intersection. Enter, enter, enter. 2.5. All right, so let's see what I've learned here. Let me switch over to a pen. Let me go back to my graph too. How's this thing drawing? Okay. See that little part right there? The origin, 5/3, 2.5. Why did they do that? What is that even there for? Like, this is just some extra stupid crap. Of course 1, 0 is 1 centimeter from the origin. Anyways, your triangle's got this curvature. And we have an intersection here, and it's the origin. This is the triangle they're talking about, okay? So they just threw some crap in there. This was 2.5, I think, and this was 5/3. So it's 5/3 times 5/2, which is 25/6. They just threw some crap in there. I know why they did that. They threw some crap in there. Which of the following is equivalent to the cubic root of 2 times the square root of 3? Kind of interesting in its own right, I guess, but you'd be an absolute idiot if you didn't push buttons. Let's see, cubic root of 2 is 2 to the 1/3. Square root of 3, you can actually push that one in. You get 2.18 something. What is that equivalent to? I don't know. 6 root of 6 ought to be pretty small. Let's check 6 root of 72. So 72 to the 1/6. Nope, too small. 6 root of 1/8. There she is. It's been a while since I figured out how that works. If you want to change that to a 3, that's kind of interesting. Let me pause this real quick. There's something I want to look at real. So if you're curious how you do this by hand, you know as well as I do that in order to multiply like radicals, they have to be the same radical. But you take your 3 to the 1/2 and you say that's equal to x to what power? Now the opposite of the third power is to cube it. And you'd have 3 to the 3/2 is x. Funny, huh? That's what the x value is. So kind of funny looking there. So inside, what we'd have here is we'd have cubic root of 2 times the cubic root of 3 squared. No, sorry. I need my actual root to change, don't I? That'd still be a square root, wouldn't it? We'll just delete that. I'm not even sure how you do that. I've done it before, but it's been so blasted long. Push buttons. For which value of x does 3e to the 2x equal 2e to the 3x? That's obviously going to be go y1, y2. I think that's legit all that is. Move this out of the way. This needs to be the last one I do right now. 3e to the 2x. 2e to the 3x. Zoom 6er. I'm going to have to go down to tutoring in just a moment. Second trace. Second trace. 5. Enter, enter, enter. We got this funny decimal point, 4054. 0.4054. Let's see what the natural log of 2/3 is. That might be negative. Let's try the natural log of 3/2. I'm sure that's a choice. There she is. Choice E. There's a reason I knew what that was. So anyways, there we go.